Okay, welcome to the lecture 2, prerequisites of kinematics. First of all, I would like to mention that this is the heart and soul of physics and your higher studies. If you miss this lecture or do not, if you're well aware of the concepts, then no issues. If you are not new to these subjects and don't know the concepts, then please go through this lecture before studying any topic, because it will be helpful in every field you will choose in a higher studies. Okay, so without any wasting your time, I will start it. First, I will let you know that what topics I would cover today. So first of all, I will just tell you the basic speed, velocity, distance, displacement, and acceleration or deceleration. Deceleration. Okay. No, so I should better use the word retardation. Retardation. This is the first thing, and then we will just then take out the basic small concepts, all concepts regarding it, all concepts, and we will also first of all we will study the vectors and components. So these are the three major things that will be covered in this lecture. So I have told you what to do. Then first of all, I will just start it with distance. Distance displacement. Let's notice the key difference. Okay, first of all, first difference, it can be actual path covered. It is sorry one point, shortest path. Can be positive, always positive or zero. This can be positive, zero, or negative. Third point, scalar, third point, vector. And these are the basic 3 points, and if you want to add anything to this point, just you should know the difference between these two. And if you know the difference between these two, then you can write all the points which come down scalar and all the points come under vector. So primarily remember these 3 things only, and if you want to further explain your answer, expand your answer, then just take the consideration of these two, and then you can easily frame the answer. So it was just a qualitative explanation, and now let's focus on the concept. This was just a theory part. Now I will make you understand that what actually it is. Distance. No, I will just explain it with a figure. Say this is part A. This is your initial point. Take this B destination point, and take C, D, E. These are all intermediate points. Okay, so I will explain this with colors. This color is person A, and this color is person B. Okay, so person B has followed this part. It's the shortest part. Okay, to be more precise, I will just rub it off and this will be the scale and just draw from here to here. It is doing some issues, no issues. Okay, this is the point B. Confused. This is point B. So person A has followed this. Now let's take person B. He has gone to like this, then he has visited this, then he has visited this, then he has visited, sorry, there is some issues in it. Wait, I will just tell you again. First of all, he went like this, then this, then this. He covered just all the points and then he reached there. Finally, he reached there. So this green line that the person B has followed is known as displacement, and this line is known as distance. Now I will explain. Person A has covered a lot more, and he has reached the final point B. So finally he has to reach B, but he has traveled so long, and person B was very smart and he just followed the shortest part possible and he reached the point. So person B just cared about the final point and initial point, whereas person A thought that first I should visit A place, B place, C place, D place. He visited all and then he reached B. So now let's assume some numbers. Assume this has covered, person A has covered approximately 92 miles. Okay, 92 miles, and this person has covered 4 miles. Okay, he has taken time, he took time 23 seconds and he took time 1 second. So the situation is clear. I guess the figure you have done is clear. Now we will just focus on, now I will just focus on the qualitative part. Quantitative part, sorry. So in short, I will write what is given. Person A, he has covered 92 meters, and person B has covered 4 meters. He took he took 23 seconds and he took 1 second. Now let's come to play of calculations. Sorry, it's 92 miles. It's 4 miles, sorry. It's 1 meters, remember. So calculation says, let's find out this was the distance and this was the displacement. Now I am concerned about speed. Speed was 92 distance upon time, that is 4 miles per second. And it is also 4 upon 1, that is 4 miles per second. Miles per second. Now let's talk about displacement. Now let's talk about velocity. I am just concerned in velocity, we are just concerned about displacement. Always remember this thing. We don't care what is the distances. It's always remember, it just cares our initial point and final point. It is a path independent process and distance is a path dependent process. Why I'm using displacement as a path independent process? Because it just cares about the first point and the last point, whereas distance only cares about about the actual path covered. So it is path dependent. Okay, so this you will cover, I will come across this, I will use similar terms in work, power and energy. That's why I am saying today only. So now let's find out the velocity. Velocity is displacement upon time. So displacement is 4 miles. Wait, I will get better. Displacement is 4 miles. Time taken is 23, and here displacement is 4 miles, time taken is 1. So the answer comes out to be 0.174 miles per second. And here it is 4 miles per second. Can you see the difference? These are huge difference. So that's why always remember this as a key point, that distance. Wait, I will just clear the canvas. Distance is greater than equal to displacement. Similarly, speed is greater than equal to velocity. Now I have given the example of greater than. Now the question comes that how equal to? Equal to comes when there is only 2 points, say A and B, and he has followed this. This was point B. Okay. So say it is 6 miles and it took 4 seconds. So here distance and displacement is same, since person A has also gone, person A, suppose person A and person B both went at same First point and second point, they have not deviated from anything. So here the distance is equal to displacement, that is 6 miles is equal to 6. It is distance is equal to displacement, and speed here is 6 upon 4, that is 1.5 miles, 1.5 miles per second, and here it is 6 divided by 4, that is 1.5 miles per second. Since distance is equal to displacement, so both are same. Okay, so now I am clearing the canvas. Okay. Now take a very practical example to understand the problem better. It's a type of question or example, whatever you can say. Let's take this up. This is point A, this is point B, this is point C. Now what we have to do is, we just have to mark the, let's assume some quantities like this is 3 meter, this is 4 meter. Here it has taken 0.7 seconds. Here it has taken 1.4 seconds. Whereas while coming back, he has taken 1.6 seconds, and here he has taken 0.5 seconds while coming back. So now let's divide this question. In short, I will do analysis part by part. So no one get this. Consider A to B. Forget everything. We are just concerned about A to B. That's it. Here distance is equal to displacement. So we are not worried about speed or velocity. Both are same. So I will represent speed by S. Okay. Velocity by V. Distance by D. And displacement by D. This is displacement. So just a bit off, so there's no clear. No clear. Just a bit off. And distance I will represent by D. Distance. Remember these notations, or just remember the red one is for distance and speed, and blue one is for distance and velocity. So I have a short of space here, so I will just delete this. and I will just remember this, that the blue one stands for the vector quantity and the S1 stands for the scalar quantity. So I will mention in short, this blue one is for vector and this red one is for scalar. So no doubt, so there should be no doubt in notation, I guess. Now let's start. A to B, distance is equal to displacement is equal to 3 meter. Displacement, sorry, I will use this one. Now time is common for this, and that is 0.7 seconds. So velocity is equal to speed is equal to 4 point, sorry, I will just do this color, 4.28 meter per second. Fine. Okay. Now this is the analysis of A to B. Now we will analyze B to C. B to C. This part. Okay. So here distance is equal to displacement is equal to 4 meter. Sorry. Meter, and displacement and distance are equal, and velocity and speed we have to consider. So velocity is equal to speed is equal to what? We have to calculate it. And time it's a given quantity, that is time is equal to 1.4 seconds. So it is 4 upon 1.4. That comes out to be 2.85 meter per second. Okay. Now let's do analysis of B to C I have done, A to B I have done. Let's do analysis of C to B. This I have done, C to B. Let's do analysis of C to B. C to B. Here we will see this. Distance is equal to displacement is equal to how many? 4 meters. Time is equal to 1.6 seconds. So velocity is equal to speed is equal to how much? 4 upon 1.6, which comes out to be 2.5 meter per second. Now let's do analysis of B to A. Distance is equal to displacement is equal to 3 meter and time is 0.5 seconds. So velocity is equal to speed is equal to how much? 3 divided by 0.5, that is 6 meter per second. Fine. See, here are the results. As you can see, see what to do every time whenever you get any question in CBSE, JEE Mains or JEE Advanced. What you have to do, you have to do part by part analysis. And since I have done part by part analysis, because I have taken the advantage that, as you know, that A to B the path is same, B to C the path is same, C to B the path is same, and B to A the path is same. So I don't have to make separate calculations for distance and displacement of velocity or speed, so that it will be convenient for you to find out easily. Now you have find out these all 4 parts. Now I guess I can remove the figure, so let us remove this figure. No, I will try to solve it here if the space permits. Wait, I will just try to manage up the space so that I can let you understand better. Say the question says that find the velocity. The question is find the velocity and speed. Wait, we have to find out. Let's say I am now, this we have done the analysis. Now I am talking about question. What if it comes? We have to find out the speed speed. Oh yeah, what this bug has happened, I don't know. Speed is equal to what? And sorry, just I will not change the rotation so that we won't confuse you. Velocity is equal to what and speed is equal to what if time given is equal to, let's say, 3.9 seconds. Okay, now see what to do first. That let's assume a point, means let's assume an approx point where it would be. So let me consider it should somehow be, since time is given 3.9 seconds, so 1.4, 2.1, 3.7, 0.7 seconds A to B, B to C will take 1.4 seconds, C to B will take 1.6 seconds. So somehow here it will be 3.7 seconds. Somehow the points will lie in this region. This region it will lie. It will lie between this region. It's clear because here till here it is 3.7 seconds. Somehow it will lie somewhere. So we can do one thing. We are just concerned about this 0.2 seconds. That's it. Okay. So first of all, let's do till 3.7 seconds. Just remember the data that we have to find out the speed and the velocity after 3.9 seconds. I'm not rubbing anything because I think so it will make you understand better. Now see, 3.7 seconds it will be. We know that the point is here. So after 3.7 seconds, speed is equal to, find the total distance 3, 4, 5, 6, 7. A to B 3 meter, B to C 4 meter, C to B again 4 meter. That is after 3.7 seconds. So 3, 4, 5, 6, 7, 8, 9, 10, 11. Fine, because 7 plus 11 meters. So here first of all I will write the distance. Distance will be 11 meters and displacement would be, so simple, displacement would be 3 meters. Okay, what happened? Yeah, displacement will be 3 meters. Now what to do? We have the time 3.5, 3.7, sorry. Oh yeah, what to do now? Just speed will be 11 upon 3.7 and velocity would be 3 upon 3.7. So speed will be 11 divided by 3.7 is equal to 2.97 meter per second, and velocity would be 0.81. One way to check it out is always see two things, that if this speed is greater than if this speed is greater than velocity, then assume that your question is almost correct. Just worry about the calculation part, and if it is less, means somewhere conceptually you are wrong, and recheck the question again. So we have find out the distance and velocity after 3.7 seconds. So just remember 2.97 and 0.8. Okay, so I am rubbing this off. So after 3.7 seconds, after 3.7 seconds, after 3.7 seconds, the speed was 2. Was it? Wait. First of all, I will write the velocity. Velocity was 0.81 meter per second, and speed was 2.97. Fine. So it will be 2.97. So now this we know. Now what we have to do is, I don't require this thing anymore, so I will just rub it off. I just require the figure, so it will be more clear to you. This is only required. I will rub this also. It's much clear. Now I have to worry about these 2 points. So now my concentration would be only B to A path. B to A I am talking about. So B to A would be since 3.7 seconds is still B, so we are just concerned about 0.2 seconds. So let's do calculations for 0.2 seconds. We know that the speed is 2.97. So forget about this. A to C, we have just concentrating on A to B part, that is B to A. So here our speed and velocity was, speed is equal to, sorry, speed is equal to velocity is equal to 3 upon 0.5, that is 6 meter per second. 6 meter per second was our speed is equal to velocity. So after 0.2 second, what will be its speed and velocity? It's so simple. Multiply 0.2 into 6. Okay. So what it will be? 6 into 0.2 will be only 1.2. Yes, it's 1.2. So after 0.2 seconds, it will cover 1.2 meters. So the exact position would be 3, 4, 5, 6, 7. Here 1.2 means the position will be, assume this position, the final position, and this final position it is at here. From here it is, we have calculated 1.2. So from here it is 3 minus 1.2, that is 1.8 meter per second. 1.8 meter. Now the question is just a child's play to answer. So what about the speed and velocity? So easy. Velocity would be 1.8 divided by 3.9, that is 1.8 divided by 3.9 gives 0.46 meter per second, and velocity, sorry, speed would be, see, it's 1.2 meters, so distance would be 3, 4, 5, 6, 7, 7 plus 1, 7, 11, 11 plus 1.2, 13.2. 13.2 divided by 3.9, it would be 3.384. Okay, so I won't make the class longer because some of you might be bored till now. So if you like, please subscribe and don't forget to press the like button. And for further reference, if you have any problem, you can, last part, wait, let's clear like this only. If you want to, if you have any doubt or any the textbook questions you are not solving, you're not able to solve, so please drop a WhatsApp message on 86. I will just give you my contact number 191772219, and below that you just write that I am your YouTube viewer, so that I understand that you are not a spam, and I will definitely reply. I will just click a photo of the question of the answer and I will send you the reply immediately back. So don't worry about your doubts, just pick your phone and just I will answer. And one more thing, if you are finding query in any other chapter you want to ask, you are most welcome to ask in WhatsApp number. Okay, thank you and have a great day ahead.